This is John Blansett, coding problems 2 through 5. Alright, so we're going to exclude 0 and 1 from this primes list. So we'll just create a test here. If its n is less than 2, we'll just return an empty list. Alright, we're going to go ahead and set up a Boolean list so that we can track the status of each of these prime numbers as we're testing them. We need to make the list n plus 1 big, so we'll set each one to true and then we'll test each one and see if it's true or false. So we're actually excluding 0 and 1 here, and we're going to use the sieve of Aristhenus. I don't know, I probably murdered that, but it's a really efficient way of finding prime numbers. You're going to iterate, the outer loop's going to iterate through numbers from 2 to n inclusive, n being the square root of that number, since we're going to take num and exponentiate it by 0.5. That's basically the square root. That way that we know if we got all the way up to the square root of that number and there's no divisor at that point, that there's not going to be a divisor, and we can include it into our primes list. If not, we know that it's false. We can mark it true or false that way. That way, as we iterate through the list and extract the prime numbers, we'll know which primes which numbers are prime and which numbers aren't based on their Boolean list value. And then we'll just return that list, and that'll give us our list of primes. Alright, this is problem 3. Well, the first thing we're going to do is test to see for an empty dictionary. And if it's not a dictionary or it's empty, we'll just return an empty dictionary. From there, we're going to need to find out how many times each element occurs in our adict dictionary. So we'll set up the value counts, and we'll iterate through each value in adict to see how many times it occurs. And then each time it occurs, we'll increment for that value. So we're going to set up a list comprehension here to go through each one of the elements. We'll store it as unique keys, and for each key that's in adict, if that value in value counts is equal to 1, then we'll store it in unique keys, and then we'll just sort that and return it with the sorted function here. We'll go ahead and run a few tests, some of the examples you had. And the expected outcomes. Let's see how it works. This is problem 4. Alright, I've got the implementation that was given to us. So the first thing we're going to need to do is initialize the base person class using the super constructor. And we'll pass it the name. And then we'll have to set up the or define the statuses that we want to check for. And we'll set up citizen, legal resident, and illegal resident as our 3 criteria for valid residency. Then we're going to check to see if the provided status is valid. So we'll create a test for this, and if it's not valid, then we'll make sure that we raise a valid error flag and notify the user of the invalid status. Next, we'll set the status, and we'll use the self attribute for all this. Do a couple of examples. And I'll have to create a try here so that we can actually catch this error. And first thing we're going to do is set A equal to a new US resident object, and we'll pass it the name Tim Beaver and of course citizen, and then we'll do an edge test in the next one after we print out the results using the get status. Quick copy and paste, a couple renames, and we will make him a non-citizen. Alright, and our exception here is we'll shoot our value error here and print out our E, which is going to be our invalid status. Correct my constructor call. This is problem 5. First, we're going to test to see if E is in the self values dictionary. Since we're inheriting the dictionary from the container, we're going to have to use the self attribute. If it is, we want to delete it, so that's what the remove is going to do for us. And then this one we just have to return E if it is in the dictionary of vowels. And these are the examples we have already. Let's get 2 and a blank. So there we go.